Hello. It's the 22nd of May, 2015, and this is your host, Paul Carr, and this is episode 8 of the Unseen Podcast. The Unseen Podcast is the unedited, uncensored, open participation, Creative Commons spinoff of the WOW signal. And tonight, before I introduce the panel, I'd like to say a few things about the podcast. First of all, one of the things about open participation is we want to get as many panelists as possible within reason. Our goal is to get 30 panelists by the first 6 months, and right now we have 2 months in, and we have had 10 unique panelists, so we're on track for that. If you are in the panel pool, then please, when you get an invitation, respond as soon as you know whether or not you can make it. And you'll see the invitation on Google+. You probably will also get an email, depending on your notification preferences. And please respond as soon as you can. That will help us plan for that particular recording session. Now, with each recording session, there's also a topics thread. You should contribute to that as best you can. If you are not in the panel pool and would like to be, send me an email at unseenpodcast@gmail.com, and I'll tell you how you can join the panel pool. As I said, we're open participation. You don't have to agree with me on anything. You don't have to have the same worldview as I do. You just have to be available and willing to engage in a civil way. So that said, I would like to begin episode 8 with our 4 panelists that we have tonight. And the panelists, I'll go in alphabetical order. So, and all of them have been on before, so we won't need to give you a bio, but we'll just say hello, everybody. First, we have Mike Bohler.
Hello, everyone.
We have James Garrison.
Hello, everyone.
David Grigg.
Hi, everybody.
And Nick Nielsen.
Greetings.
Okay, so now tonight, folks, I think we've, on the topics thread, the main point of interest has been astronomy. And I'd like to maybe make that a little more broad, sort of the human understanding of the broader universe, the universe as we can observe it. And a lot of exciting things have happened lately, and are about to happen. So, who would like to tell me what they think is the most exciting thing that's happening right now?
How about
Go ahead, David.
How about the Dawn mission to Ceres?
Oh, yeah.
And New Horizons' trip to Pluto. They're both very exciting missions.
Yeah, I'm excited about both of them. What do you think's most interesting about Dawn?
Well, it's the first time we've been to what we're now calling dwarf planets. First dwarf planet to be discovered, which is the dwarf planet Ceres, the largest body in the asteroid belt. And it's looking very interesting already. Some evidence of bright white spots on it, which probably are certain. So it'll be interesting to see what happens when we get down with that spacecraft and figure out exactly what's going on down there.
Yeah, I have my own speculation of what those bright white spots are. Anybody else want to share some ideas? Okay, well,
I personally been thinking that they may be either like from a minor impact where the surface has been scored. Think kind of like the Nazca lines, which are kind of reflective.
Yeah.
Just minor meteorite hit.
Yeah, I think that's actually a pretty probable explanation. I'm not saying it's aliens, but never. But it's not alien. I can't do my Giorgio impression very well. I'm sorry. Yeah, it's really interesting though. It's got everybody speculating. It's almost like it's like a close contest for the Super Bowl. What's it gonna turn out to be?
Are we assuming that?
Well, the obvious likelihood is ice.
Yeah.
It's interesting, isn't it? Really, the fact that ice could be retained on a small body like that.
Yeah. Well, I mean, it depends on how long ago that ice was exposed, right? But yeah, Ceres is far enough away from the sun and big enough that it could retain ice, at least in small quantities. And
are we assuming that an impact may have wiped away surface dust and debris and then exposed ice beneath, and it's the ice reflecting?
that's what I think it might be. And James seems to have had the same idea. Yeah.
Either that or, I'm going to say either that or some material that is reflective, like glass, maybe a silicon type thing.
Quartz or something.
Yeah.
Yeah, it's reflected from a wide range of angles, so it's not a specular reflector; it's a diffuse reflector. So ice is definitely the best candidate. But the real interesting thing would be is if it was ice that had just made its way to the surface under its own power. That would mean that Ceres is a dynamic and active place, which nobody expects a planet that small to be that active. So if it's an ice volcano, that is really important, I think, from planetary science perspective. And I think that's what the scientists are rooting for, that it's actually a volcano of some kind, of ice that's making its way to the surface under some kind of pressure.
Where would the energy come from, Paul? Where would the energy come from for that? I mean, we look at some of the moons of Jupiter and Saturn, and they're very active because of the tidal forces. There aren't any tidal forces on Ceres.
Well, that's
so where would the energy come?
It's a very good question. Nobody knows. I think it could be energy that's residual from the formation of the planet. It could be lots of things. But yeah, you're right. It's not tidal forces. It can't be that. It's something else. But we'll see. I think the impact theory is probably going to hold up under examination, because if it was really an ice volcano, you'd expect to see it in more places on the planet. And
there are a few other spots, aren't there?
There are a few other spots, but they're not anywhere near as large or as bright. And just the way it looks like something splattered. Like something. It looks almost like a 20th century painting. Somebody splattered paint on it or splattered ice on it. So we'll find out. I think that's really, it's great that this is such an open thing, that NASA is sharing their data with us almost as soon as they have it, and they're not keeping it to themselves. They're letting us know right away. I'm sorry, Mike, but the conspiracy theorists are not going to have a field day with this.
Oh no, they are.
Oh, they are.
They are. They will.
They'll find a way, even though NASA's releasing pictures almost as soon as they get them.
The more pictures, the more fodder for the mill.
The face on Mars. That's all I'm going to say.
Exactly. But
is it possible that a significant impact long ago in the past could have heated up something subsurface that would be leaking out now, as it were?
I wouldn't say long ago, but thousands of years ago. Yeah.
That's what I mean. Thousands, tens of thousands, long enough that the crater would no longer look fresh. If there were a crater, would have to be some kind of crater if the impact was large enough to warm stuff up underneath.
Yeah, I think that particular crater is probably pretty old, but the impact could have been in the crater itself and warmed it up and caused it to release ice.
Or an impact somewhere else that traveled through subsurface channels of some.
Yeah, I wouldn't rule that out. I think that's what's going to have to happen is they're going to have to spend a lot of time in orbit, gather a lot of data, and then model it very closely. And that's really where the answer is going to come from, is for looking at the models. And And before you can do those models, you're going to need a lot of information. You're going to need a lot of. So, hi James. Hi, what's his name? What's your boy's name again?
It's Colin.
Colin. Okay. Yeah.
Yeah. Sorry,
Colin likes to come in and say hello from time to time.
Skeptic in the make.
Yeah.
So I was going to say on the impact, isn't it feasible that there was a small comet or a fragment of a comet that could have struck it too, and that may be actually where, if there is ice, that it came from? Maybe.
I would think that ice would have been vaporized, though.
It's a small fragment of a comet.
I think, yeah, well, if it may be. I think more likely ice was already there and it got exposed. But, again, it's kind of, what I think is cool about this is that the public can sit and speculate like this, and the scientists are right alongside us saying, hey, we're working on it, and they're releasing the data as fast as they can get it. And now it isn't just cameras. Go ahead.
Are there spectroscopic studies? Is the instrument that do a spectroscopy?
Yeah, they will be doing some of that. I'm blanking on what their spectroscope is called. But yeah, they have what they call a visual infrared spectrometer, they should be able to get, if nothing else, detailed color information. So I think that, but probably more like actually a real spectrum. So, they'll have a lot more data than what they can actually show on a picture, and including gravity data, which they get from monitoring the radio signal of the vehicles that goes around the body. So with the gravity data and everything else, they'll probably get a pretty good idea of what that is down there. But that often takes months of analysis. So it's not instant science. And I'm sure this will be a subject of scientific debate for some weeks at least, if not months. But
months or years, until an astronaut gets down there with a rock hammer and takes a look closer.
That could be many, many years. Yeah, unless you've got more money than I'm aware of being available. It's. I mean, there's no technical obstacle to doing that's any greater than sending a man to Mars or a woman to Mars, but it's still very, very difficult and expensive. Now let's see. Now, somebody mentioned New Horizons. We're flying by, I think it was David. We're flying by Pluto this summer, and it's getting closer all the time, and the LORRI instrument on board New Horizons, with the long-range reconnaissance imager, is sending back images that get more detailed every time. Seeing the moons of Pluto, it's less than half an astronomical unit away. So we'll have a brief encounter with a dwarf planet. Which I'm sure Alan Stern will say, no, it's just a planet, doggone it. But I really like Alan Stern. He's the kind of guy that makes the space program go. And he is determined that everyone treat Pluto as a planet. And he says, but, also Eris is a planet, and Ceres is a planet. And, but he he's the principal investigator for New Horizons and has been since the beginning. But he's the guy that put the he's the guy that put the proposal together, even back when Clyde Tombaugh was alive, and Clyde Tombaugh was one of the member of the science team. Clyde Tombaugh is the guy who discovered Pluto back a long time ago. That's pretty exciting, and stay tuned. I think we're going to have some really great images, and they're also, in addition to images, they have spectroscopes on board and they have particle counters. And one of the most important things they'll be doing is looking at the radio signal coming back in detail to measure the exact gravity of Pluto, and they'll also get pretty good They should get pretty good images of most, if not all, the moons. There may be more moons than we've known about previously, so that should be good. So this summer is going to be fun. And see, I believe if I'm not mistaken, the close encounter is in August. See,
perhaps July.
Sorry. July. Yes. So it's coming up very soon. I think there's a countdown timer on the APL website. Where you can see the exact number of days and hours and minutes and seconds until the closest approach. At pluto.jhuapl.edu. There it is. 52 days, 10 hours, 20 minutes, 45 seconds. Oh, so 43. No, 40. No, I can't keep up with that. And I should point out the mission elapsed time is 3,410 days, 6 hours, 29 minutes. It took a long time to get out there. More than, about 9 years. 9 years and change. And this was the fastest moving object that has ever been launched, the New Horizons spacecraft.
I thought the Voyager probe that went outside the solar system.
It is actually, when I say launched, I mean, at Earth departure, it was the fastest. Voyager did a number of gravity assists that made it go. In fact,
it out further.
Yeah, New Horizons did a Jupiter gravity assist short ways into its mission. Did a lot of good Jupiter science at the same time. They are, okay, so it's 52 days away from this recording, and probably about 51 days away from when you'll hear this podcast. So, definitely stay tuned. Go to pluto.jhuapl.edu. They will have all the data up there. They'll get it up there as fast as they can. However, I should point out that given the long distance to this spacecraft, it's going to take a long time to get all the data back. So you have to be patient. They won't be a lot of, they will try download the best pictures, the best closest approach data is first, but that will still take many days. And then it'll take weeks and weeks to get everything back from the close approach. So, and that's assuming no problems. So, I don't think they'll have problems, but, because I know these folks and I know that they have planned very thoroughly and their hardware is working just perfectly. So everything should be fine. I worked, by the way, personal note, I worked on New Horizons, for, about year and a half, 2 years, before it launched. And so, I have a little bit of connection to it. So now let's talk about the James Webb Space Telescope. Now, this is in terms of space telescopes, it's going to be a monster. It's going to be way more powerful than anything we've seen before. But it's not going to be it's not going to have the kind of aperture that we saw in that we're seeing in the telescopes that are going in now in Chile, the extremely large and the very large and the what did they call that? The overwhelmingly large telescope that's in planning right now, the OWL-T. A lot of it
really creative with those names.
Well, people who stay up really late every night, watching things move very slowly, tend to come up with names for things.
Yeah.
We're going to run out of adjectives eventually.
Yeah. Well, I mean, after the overwhelmingly large telescope, I think that they're out of acronyms. They're going to need something completely different.
The humongous telescope.
Yeah.
Be bigger than the last one.
The unimaginably large telescope. Well, I mean, with the radio astronomers were a lot less. They used a lot less hyperbole. They just called it the square kilometer array, right?
Yeah.
And you may think that's really big, but someday there will be a 10 square kilometer array or a 100 square kilometer array. So, they decided not to call it the extremely large radio telescope or anything. Even though it's going to be an incredibly sensitive radio telescope. But, and by the way, let me plug the WOW signal a bit. I did do an interview with Andrew Simeon, who's an astronomer working on the, among other things, the square kilometer array and preparing SETI experiments for that. So that's a really, really exciting instrument. Another instrument came in on the news this week. I'm not going to talk about it too much right now, but because I need to get more data. I need to get an expert in to really help me understand it better. But an omnidirectional radio telescope that scans the whole sky in longer wavelengths, not in all the wavelengths that we're interested in, but that is a step in the right direction. And I'll have more on that in the near future. I may do something on the WOW signal about that.
That be orbital or ground?
It's ground based. It's in Owens Valley, California. And it's an array of very simple elements that scan the entire sky, generates enormous amounts of digital data. We're just getting to the point where we can actually handle the computing load required to do an omnidirectional radio telescope. Because you have to process vast amounts of data.
There's an online video of Kurzweil giving a hour-long talk at the SETI institution, and one of the main topics he brought up, and many people brought up, is the need for more computing power to be applied to SETI for it to be an effective search.
Yeah, well, that's happening, and in fact, it's getting easier and easier to access more and more computer power. I mean, just think of how much Amazon can make available. Amazon sells their excess CPU capacity, for example, and you can access it at a market rate, and it's getting to more and more sophisticated every year, where you can actually, using standard interfaces and standard protocols, say, I need this much computing power, and it's just out there in the cloud, and you just get it. You have to have the money to pay for it, but it's there. It's huge. How much? Just eBay alone has vast amounts of servers, and they all do. Yahoo, eBay, Google, all those big internet
There's
companies.
a lot of capacity out there, and they're always building up more.
And at 3:00 in the morning in North America, there's not a whole lot of demand for eBay. There's some, I know, it's probably me, but
I wonder how much of that power is being used to mine bitcoins.
A lot of it is, actually, yes. We did a show on that in episode 4. Yeah. Bitcoin mining is not just Bitcoin, but all other kinds of cryptocurrencies are being mined constantly. And the whole scheme of Bitcoin is that you have to have more computing power to prevent fraud. And but that's all available. It's out there, and it's becoming a planet-wide phenomenon. In 10 years, people will think nothing of accessing a huge server farm in China from Scotland to process radio telescope data, and they'll get it for prices that today would seem absurdly low. And that's going to happen, I think, and it is happening now. And some of I know one, the satellite company that Google recently bought out was using cloud computing to plan their observation time. So that was they would go out into the cloud and grab the processing power they needed to optimize their observations. So, and of course, now that that's part of Google, it'll even be smoother. But but anyway, I wanted to get back to James Webb. James Webb Space Telescope is a very large space telescope by, much larger than Hubble. It has a segmented mirror. But the reason they're going with the space telescope that's costing upwards of $8 billion, probably more. I'm not sure what the official number is. There's an official number, and then there's probably the number that will come out in the wash. It'll be higher. Could be close. When we're all done, it's going to be something like 10 to the 7th. I'm sorry. Well, 10 to the 10th dollars. You could build a lot of ground-based assets for that much money. What they are doing is they're building an infrared telescope it's not purely infrared, but it has a lot of infrared capability. And that allows them to justify a space telescope. And it does. I think it does quite clearly justify it, but it is enormous amounts of money. For that same 10 to the 10th dollars, you could build an overwhelmingly large telescope. You could build two of them. You could build one in the northern hemisphere and one in the southern hemisphere.
Do you know what it was budgeted for when it was first proposed?
Oh, I don't know that number off the top of my head, but it was a lot lower.
Has it gone up by an order of magnitude, or?
I don't say an order of magnitude, but probably a factor of 2 or 3.
So what inflates costs of projects like that? Wanting to add all the accessories, or just because costs go up?
No, I don't think it's so much gold plating. I think it's that it's a combination of politics. How do you get a program initially funded? You tend to be optimistic in the cost estimates.
So you lowball it.
Well, you could call it lowballing, or you could call it delusional. No, I mean,
all volunteer staff assume.
Mike, did you want to say something?
Yeah, I was just going to say there was an article in Science, the Science Journal, on after Hubble. It's in the April 24th, 2015. The original price on the James Webb was $1.6 billion. They overran it. The current they're capped at they're supposed to be capped at $8 billion. It goes over that.
Well, it won't, but at some point you get too big to fail. But
yeah.
You talk about building ground-based telescopes, but would a ground-based telescope be able to see the wavelength that?
No, there are infrared wavelengths that are effectively blocked by the atmosphere. There are a few notches where you can see infrared through the atmosphere, which is why there are some infrared telescopes on the ground. They see through those notches, if you will, but by and large, you can't see very well at infrared. So the space
You
telescope,
gotta have the right angle too, don't you?
right? Well, yeah, you have to,
Like sunsets are red because that's where the red wavelength is coming through the atmosphere.
right. You are stuck with the geometry you get on the ground as well. Whereas great thing about the James Webb is it's way out there at
L2,
it's at Earth Sun L2.
million miles out. Yeah.
Yeah, it doesn't really have to worry too much about. It can integrate for a very long time, much longer than a day, much longer than 8 hours, which is probably the most you'd ever have on the ground. And the as a result, you can get really, really, really good images of both distant galaxies, planetary systems, debris disks, all kinds of interesting objects out there that have strong infrared signatures. And as we discussed in a few episodes ago, you could do some infrared SETI with it. You could look for things like evidence of asteroid mining, evidence of Dyson spheres, things like that. It's got all that capability. You'll never be able to completely duplicate that on the ground, but you could easily imagine, in terms of astronomical knowledge, you could take that $8 billion and spend it, in other ways. Now,
But doesn't the James Webb Telescope have the possibility of making discoveries that would be qualitatively distinct from what you could get on the ground?
I think it does. But then again, an extremely large light bucket on the ground could also get qualitatively different discoveries too.
Yeah, that's true.
Now, is it a deep field? Is it a deep field telescope or is it a wide field?
It's pretty. It's pretty deep. Yeah.
So it's a pretty narrow view of what you're gonna.
Yeah.
Pretty focused on a smaller area.
Right. Yeah. It's not like WISE, which WISE was a sort of a survey telescope, much smaller. But yeah, James, and much cheaper. James Webb does not rely upon coolant, on a kind of liquid coolant to keep it cold. It's using thermal shields and being a long way from the Earth to keep it cold.
I was going to ask about that because when I paid attention to the Herschel mission, when that went up, I think it started returning images in 2009, and at that satellite is already unserviceable because it's evaporated away or lost coolant somehow, so it can no longer function.
Yeah, well, so is WISE. I mean, WISE. Most of the infrared bands are far too noisy on WISE to be useful now. WISE is a low Earth orbiting telescope, but because James Webb is so far out there, they can keep it cold passively, and that means it can be out there for a really long time producing infrared data. So, it potentially many years.
So there's a double justification putting it way out there at L2, getting away from the Earth's atmosphere and the cooling and the lack of interference.
Yeah, well, I mean, you don't have to really worry about Earth being in the field of view. Earth is in the same direction as the sun. You don't really want to look over that way anyway. So it's there's this vast amount of sky that's open in front of you that you can focus on for as long as you want.
Doesn't go away.
And you can stay cold that whole time. You can stay. What they had to do was design a massively complex heat shield to keep the sun off the telescope. It's very large. It's very cleverly folded up for launch, but it will, when it launch, it will deploy and unfold. And they've been testing that pretty rigorously, and it will protect the telescope from the sun's light, essentially heating it up and keep everything nice and chilly. the solar panels will provide enough power to keep the warm parts warm and the cold parts cold, and it should last out there at L2 for a long time. It's basically not serviceable like the Hubble was, although you could, in principle, I think, service it if you were determined to do so.
What I read is it was built because it was going to be put so far away. Is they built it without consideration of service because they assumed nobody was going out there anytime in the next year.
People have considered robotic servicing for that because you're talking about such a huge investment.
Yeah,
it might be worth spending $1 billion to send a robot out there to service it if you can extend its life 5-10 years.
See what the economy what the economy is like in 10 years, and see if people would want to spend money on.
Yeah, well, we'll just put a Kickstarter together, and
and by that time we'll all have enough money to make it happen.
I won't. My daughter rides horses, so I'll have to.
Paul, does it need the James Webb, because the L2, as I understand it, is not as stable. I mean, it's quasi-stable, but it makes things.
Yeah, it will have to do maneuvers from time to time. Yeah, to stay there. Yeah.
So it has some onboard propellant.
Yes, it does. It doesn't need a whole lot. It's the amount of so-called delta V, that is how much velocity change you need, isn't a great deal. It's it's on the order of 10 meters per second per year or something like that.
Is it primarily powered by solar panels?
It is entirely powered by solar panels, yeah. But it's not that much further from the sun than the Earth is. It's only 1 million or so miles further away. So it's essentially gets the same amount of power that an Earth orbiting satellite would get, except that there's no eclipses at all. So, you don't need actually a larger panel to power it as you would for, say, a low Earth orbiting satellite, which is going to have eclipses. So, it's actually, I think, tremendous amounts of effort and put into the design and trying to make it as reliable as possible. I think that it's almost certainly going to be a success if the launch vehicle that it's riding on is a success. And now launch vehicles do have, a finite failure rate. It's not zero.
A Mexican satellite just got lost a week or two ago.
Yeah, and the thing is, the Russian launchers, it
was a proton booster that.
The Proton has actually been pretty reliable over time, well over 90%, but it's an old design. It's a probably the third generation of engineers working on it now. So over time, these designs can become hard to manage, and a lot of the designs in Atlas and Delta are based upon designs that are Cold War designs as well. So, although they've updated and upgraded everything over time, they have. It's real difficult to maintain the knowledge base well enough to assure that the vehicle is going to launch successfully every time. In fact, I don't think anybody in the world can claim that their launch vehicle is 100% guaranteed to work every time.
That would be silly to try to get a search.
Yeah, there's always some failure rate. What you're doing is you're putting your extremely expensive payload on top of essentially a controlled chemical bomb.
Right.
And you're lighting it off. You hope the control is maintained, but if it's lost even briefly, the whole thing just completely disintegrates. So, we're getting better at it, but 100% it's not going to happen. So there's always some chance that you could lose the James Webb Space Telescope in the first few minutes of its mission. I think if you get through that, it's going to be fine. It's going to probably live for 15, 20 years.
Even if we assume that the primary business in space over the foreseeable short-term future is primarily going to be about satellites for Earth use, given how crucial these are to the economy now, you would think that more people would be interested in something like a Skylon space plane because it doesn't have a lot of those vulnerabilities. Chemical. I mean, it's a chemical rocket. It's a hybrid engine, but presumably because it has wings on the side, if something went wrong in the boost phase, you could come down to a smooth landing again and not lose your investment in the cargo.
Yeah, but we said that about the shuttle too. All right, we had
That's true.
we had transatlantic abort. We had return to launch site.
But the shuttle was a conventional vertical takeoff. It's not a horizontal takeoff and landing craft.
Yeah, well, I mean, I think the jury's out on whether that's more reliable or less. You have to fly something to really know how reliable it is. And you can ask SpaceX. They have a very reliable launcher now, but tell you what, they went through a lot of failures early on with the Falcon 1. The
reason they call it rocket science. It's not easy to do.
It's not easy to do, and particularly if it's a new rocket, it's going to have growing pains. Ariane have gotten their rocket pretty reliable now, but holy cow, they had a lot of failures in the early days of the Ariane 4. They've seemed to have largely fixed that, but also Atlas and Delta have had their failures too, but now lately Atlas and Delta have been very reliable. So, it's possible that it doesn't mean that everything possible that could possibly go wrong has been anticipated and headed off. When things do go wrong, it's almost always something that nobody thought about.
The unknown.
It's the unknown unknowns or just the ignored unknowns. Yeah.
The way people talk about NASA engineers is that they throw up every possible conceivable scenario, so there aren't many things that are left to ignorance, although there are, of course, what the engineers call the margin of ignorance, so can't be eliminated.
Right. Well, I mean, I'm a NASA engineer, so I can tell you they are extremely careful and do think about a lot of things. But, you still have this problem that nobody can assure you that they've thought of everything. And that's the unknown unknowns, or perhaps simply the overlooked unknowns. If you go back to the Challenger disaster, there we had known unknowns. We didn't know how well those O-rings would perform in very cold temperatures. We had an anomalously cold morning that morning in Florida. If you look back at it, almost anybody would have said, I never would have launched that vehicle, but they did. Have those lessons been learned? I hope so.
Well, you always learn the lesson of the past, but it still doesn't mean there aren't more unknown unknowns in the future. They're going to come around the blind side.
Yeah, well,
I mean,
in both the case of Challenger and Columbia, there were known problems. The debris strikes that they were getting from on Columbia, the foam strikes, they knew about that, but they somehow convinced themselves that it wasn't a problem. So that everybody, I'm going to tell you, everybody in the space industry thinks about that all the time. How can we avoid being those guys? We don't ever want to be those guys, right? So but on the other hand, there's not an infinite amount of money. There's not an infinite amount of time. You have to prioritize what you think about and what you address. And
but NASA, of course, has become very risk averse partly because of those, and it's very subject to popular opinion because it gets its money from a democratic process.
Yeah, of course.
It has to be aware of that, but under the circumstances of the Cold War and the space race, enormous funds were poured into it, and an accident did not stop the program. When there was a tragedy on Apollo and 3 astronauts burned in the capsule before when they were on a test run. That didn't bring the Apollo program to a halt, but with the space shuttle program, the accidents brought it to a halt for a year or two.
Yeah. I think if we had something like the Apollo 1 fire now, it would shut down whatever program that was on.
Unless the political conditions are changed. Like I say, if you have a Cold War space race going on, you accept a certain rate of casualty. When you're doing a civilian space program for science, then there's much less of a tolerance for risk and for failure and for fatality.
Right. I agree with that. Yeah. There's certainly a, I'm well informed of the NASA culture. They have had a lot of success with being extremely careful and proceeding slowly and at more cost. But they've had a lot of successful missions that way. But overall, proceeding into space with the notion that there can't be any accidents, there can't be any mishaps, there can't be any deaths is almost certainly not a starting position that's going to work. And we have to accept that it's risky and that anybody who goes to Mars is putting their life on the line. No more so than a soldier who's sent to Afghanistan, or Iraq, but still, it's not, your neck is stuck out at that point. And then we have to accept that. And until we accept that, I think we're not going to make much progress.
I think people do widely accept it, but it's the institutional culture that is risk averse and the public opinion that is risk averse. Well, for example, we all know that when I can't remember the name of the company advertised for volunteers to go to Mars, they got tens of thousands of people who were ready to go, even though they didn't know any details about what was proposed to be done. Yeah. And I think if you opened it up, I think if you opened anything up to people, even knowing that it involves a risk, there would be a lot of people who would jump.
Yeah, I agree, and I would perhaps be one of those people, although I'm probably a little bit older than what they're looking for. But now I didn't think Mars 1 was a very good plan, and I'm pretty sure it won't happen. But if you give me a plan where I have a decent chance of surviving on Mars or coming home, I'll take either one. I'll go.
And many others will too.
Just I'll ask this for a fighting chance. I don't ask for, I don't ask for certainty at all. And you're not going to get certainty.
No.
Not even if you spend $100 billion or $200 billion, you're not going to get it.
But in a way, it's like the soldiers going to Afghanistan. What you want to know is that, one, you're going for a good cause, and two, that every possible care has been taken to guard your safety, and then you're prepared to take a risk. And that was the thing about Mars 1. It didn't look at all like it, either a good cause or really that the risks had been properly assessed.
Yeah. Well, I don't think Mars 1 will happen, my personal opinion, but because the amount of money we're talking about is, of course, much larger than anybody initially thought about when they started out. That's pretty much a universal human activity. Is when you start out on a big plan with a lot of vision, you tend to you haven't thought of everything, and it's the everything that's going to cost all the money. And I read today all the time about people planning world trips to other stars, and I go, well, that's a pretty cool idea, but have you really thought about how much what that's going to involve? And
well, as with the NASA engineers trying to get through every risk in their things, the people who do think about these long-term generational ships, they have spent quite a lot of time elaborating different scenarios. But once again, the same principle applies, and mistakes will be made, and things will not be anticipated, and there will remain unknown.
Yeah, well, the other thing is that my view of it is, from lots of experience in this, that you don't really know what you're getting into till you go and do something similar to it. So, with Hubble, we didn't really know what we were getting into. We muddled through and made it a success. Success. And now it was something like that. So perhaps we can make that a big success without so much pain and suffering. That's without the shuttle servicing, Hubble would never have really been a big success. But it
would have been viewed as a horrible boondoggle and as an enormous failure, and people would have lost their careers. Though,
as it stands, but now each of those shuttle servicing missions cost an enormous amount of money, and we don't really have that capability anymore. So, they can't require that anymore. They have to get it right the first time, and I think that they can. I think they can get it right. And it's not only is it not the first space telescope, it's not even the second or third. There have been lots of others.
Just as a hypothetical, don't you think that a Soyuz type capsule could be launched from the International Space Station to service a satellite in low Earth orbit like Hubble, even if we don't have the capacity of the shuttle?
But hypothetically, yeah. I don't think there's anything like that capability online at the moment, but it's possible. The problem is most of the cost of the servicing mission has not been the launch. It's been preparation for it and all the, it's a big deal. It's not, there's a lot of guys, swimming around in swimming pools at Marshall Space Flight Center trying to figure out how to do it.
Right.
It costs a lot of money. You should see I saw the paperwork once for one set of tools, for the astronaut tools for the Hubble servicing mission. Just the paperwork. I'm not talking about the tools themselves can fit in a bag, right? The paperwork stacked up 3 or 4 feet high. Just the, this is how NASA does things. Now, it works for them, right? They want to see a lot of documentation. They want you to be very, very careful about every test, every element of the design, every analysis. But and there's no way that NASA can not do it that way. They just culturally not capable of it. So it's going to cost a lot of money. And I think that personally right now, I think that there's very little chance that it'll be another Hubble servicing mission. They've moved on.
No, I think you're right. I don't think there'll be another servicing mission, but certainly if something goes wrong with the James Webb Space Telescope, parallel to what happened with Hubble, there would be a real question of whether an attempt would be made to save it, or if it would be allowed to die and be a colossal failure.
I think, I agree. There would be a soul searching process going on there. Do we take the NASA budget and basically wreck it for another couple of years, or do we
invest the entire thing?
Thing is, the James Webb has eaten all the money. I can think of at least 2 missions that have been canceled for James Webb. One is LISA, which is the long wavelength gravity wave experiment. Another one has been the terrestrial planet finder.
Yeah, I was disappointed at the terrestrial planet finder.
Good missions, good designs, a bit risky, but they had to go because the money was not there because it was spent on the James Webb. That's the kind of trade-offs you make every day in those kinds of situations.
See, I'd be worried if something goes wrong with it. Some of the politicians that have been pushing to cut NASA's little scrimp of funding anyway would say, see, they can't do this. Why give them any money?
Yeah, I think they probably would say something, probably a little more subtle than that, but they would say something like that. They would say,
Yeah, unfortunately, I lack in the subtlety department. So.
They would say something like, no good money after bad or something like that.
Yeah.
And what's the argument against that, right? When you could take those $2 billion that you would need, probably, I would guess about $2 billion, what it costs, a servicing mission would cost, and build an overwhelmingly large telescope with it, or build a whole bunch of small astronomy missions, or build a terrestrial planet finder.
It would be a tough call, and
yeah,
careers would be decided by the.
Yeah, I mean, Freeman Dyson's always made the argument that the smaller missions do more science for the buck, right? Like IRAS, which was a small, cheap mission that went up, I think in the 70s, a little infrared telescope, revolutionized our understanding of the universe for a relatively small amount of money. Terrestrial Planet Finder could do the same thing. Terrestrial Planet Finder, a bit more expensive, a bit more elaborate, but still it got canceled because, well, it was a risky mission, but the amount of money just simply wasn't available anymore. What else got canceled? Oh, Lisa, I mentioned Lisa. Lisa is an incredibly ambitious mission. I think the Europeans may go ahead with that. I hope they do. That was detection of gravity waves in space. Very, very long baseline. You could potentially detect gravity waves from the very beginning of the universe with that. It was on track to happen. It's not going to happen now for a very long time. So, that's the kind of trade-off you make. But, to a certain extent, there's also a very strong argument for building a big observatory class institutional mission like James Webb, where you'll have two generations of astronomers using that instrument, and doing astronomy from it, doing really good astronomy for a long time. And not just answering one question, but really discovering things that nobody expected. I mean, before Hubble, I think Hubble really did change our view of how the universe is put together. Before Hubble, we didn't really know how many black holes there were out there, how many galaxies had black holes in the middle of them.
And because it was a visible spectrum telescope, it was something everybody could identify with when they saw the picture.
Yeah, well,
the ultra deep field it was a profoundly influential picture.
It was, yes, yeah. Hubble did took absolutely gorgeous images for a whole generation. And
my favorite's the Horsehead Nebula.
Yeah, there's a lot of them. I mean, just from the galaxies alone, we got these incredibly sharp, detailed pictures that allow us to actually can count the stars in Andromeda Galaxy with those images.
One of the things I found very interesting reading about the James Webb, which is one of those things you think in retrospect, of course, is one of the reasons it's infrared, is that it's going to be able to look at galaxies which have huge redshift. And of course, the visible light in those galaxies has been redshifted down into the infrared. And so That's one of the reasons that James Webb is in the infrared. Actually, that's my understanding anyway.
Yeah, that's true. Yeah, some of those redshifts are so high that there's basically no visible light coming from those galaxies. Yeah. I mean, Hubble could see near infrared, but it couldn't see much further than that. And so that's... What about... James suggested a topic that we can maybe touch on briefly here before we head out, which is we've talked about human space flight that's been used to rescue telescopes. And we also know that there's been a lot of robotic space flight. We've had an incredibly successful robotic planetary exploration program. Do we need to also have a human exploration program for scientific reasons, or is it, or what's the rationale let's say, yeah, we agree that we want humans to go to Mars. We want humans to go to asteroids. We want humans to even go other places in the solar system. Is the rationale primarily scientific? Is it sending a geologist to Mars because a geologist is better than a rover, or is there something else?
I think a primary reason to send a human is, no matter how advanced our robotics get, our visual, the photographic capabilities get, there are some things you can't do just by looking at a screen by operating a control. Sometimes being able to, say we do land somebody on Mars, the fact that they can take a rock into a lab, once they take off and actually feel the texture, that's not something you can really do with any kind of robotic. And then there's, the slight, I would say pride's probably a big part of it, in that we did something instead of just sending a robot to do. People have robots mowing their lawn. So, I think sending a human, probably you'd get more immediate results instead of having to compile all the data, instead of having to wait for results. You would actually have somebody on hand able to begin the interpretation.
Surely one of the reasons for doing it is that humans are very flexible in terms of, if they see something unexpected, they can do something about it, whereas a robot can only really do what we've planned for it.
Yeah, that's another reason, and not just mentally more flexible, but physically we're less apt to get stuck in a crevice and not be able to move. We don't rely on a solar cell. We don't rely on, we need, our peanut butter sandwiches, yoo-hoo, but for the most part, we're able to function in a lot more diverse kinds of environments. Most of the rovers, and Paul might be able to tell me if I'm right or wrong, but they are designed for a very specific set of criteria. They can only go certain places. If the terrain's too rough, too unusual, they're stuck. They have to back up, find a way around it. Humans, for the most part, can find a way over, through, or under almost anything.
That's true. Although I'll tell you, Curiosity is a big step forward over the rovers before it, because it has the nuclear battery. It's not constrained to where it's pointing relative to the sun. But given what they've done with the rovers, I think that in spite of all the constraints they've had, a lot of careful planning and engineering goes a long way. Humans could say, "Oh, that's a funny looking rock," and pick it up and hit it with a hammer, maybe, and look at it with a hand lens, in a few minutes, whereas that process would take a day or two to plan on with a rover. So with humans you could make much faster progress, but the cost is, of course, you have to keep that human body alive in that hostile environment. So you need a lot of mass. You need just a lot of dumb stuff. You need oxygen and food and yoo-hoo, tang.
Yeah.
But that's that's really just a problem of getting enough mass up there. You don't have to do anything particularly clever or sophisticated. You just need to get the mass up there to support the human. And then once the human's up there with enough water and enough comic books or whatever it is to keep them going, they're fine. And so it becomes a problem of, launch costs, really. And it turns out it's a lot of mass just for one or two humans.
You left out one thing, and that's that with humans we actually have to be able to bring them back.
Well, I don't know. I think a lot of people.
Not if you're Mars One.
I think a lot of people would go if they felt they could survive. and not come back. At least not come back at any definite time. But yeah, bringing them back. If you assume you have to bring them back, yeah, that's true. It's vastly increases the amount of mass you have to send to Mars to do that.
I don't think there's any question that there's an enormously much more expensive to do science with human beings than with robots, and robots are always going to have their place and will do some of the best science that's available. But I think we should make a distinction between the kind of science that gets done. If we take as an analogy, 100 years ago, when there was a race to get to the poles first, Shackleton and the others who were going both to the North Pole and the South Pole, they were scientific expeditions, but at the same time they were adventures. These people wanted to be the first man on the North Pole or the South Pole, and I call that adventure science. And I think that once the launch cost gets down to the point where human beings can routinely go into space, that you're going to see a return to the adventure science that was common on Earth before the entire planet was settled. And we don't have that now. Right now we have the economics and the technology to do robot exploration in space, so that's what we're doing. But that encourages a certain kind of institutional model of science that's not much about the individualism of the adventure science of people like Humboldt, who went to South America, and the polar explorers, and the guys who went down to the Challenger Deep in their bathysphere.
Mm-hmm. Well, I mean,
yeah, but you'd almost have to bring the age of adventure too.
Yeah. Well,
if it gets cheap enough, that will happen.
Yeah, I mean, the age of adventure was because we had a big frontier that was reachable, although with difficulty, right? And that frontier on Earth is gone, but it's out there in the solar system, and we just have to get to sort of the same level of difficulty, and we're there.
Yeah, parallel level of difficulty and be in a similar situation.
And you also have to have a parallel level of risk, and you have to be willing to understand that, your Arctic expedition might all die, and
many did.
Yeah,
and many gladly went on adventure science expeditions and died.
Right, and probably very likely, as Jeffrey Landis said in one of his books, Mars is for heroes. Mars is not going to be easy or cheap or safe. And those who go there will gladly accept that reality. Folks, I think we've had a really good conversation at this point. I'm going to kind of like you to sort of wrap it up a little bit. I'd like to sort of go around the table, starting with Mike, and then David, then James, then Nick, and have a little sort of last word. And then we will, then I'll say a few more things about the podcast and send everybody home. Okay. So Mike Bohler, any last thoughts?
Well, I didn't get much of a chance to talk much during the show, so if you don't mind, I can throw a little bit of extra here.
Sure.
Because I'm the type of person who believes that we should be getting out. I mean, humans should be getting out into the universe. I mean, we need to be getting to the moon. We need to be living on the moon. At some point, we're going to have. I mean, if population growth, all that kind of stuff, we need to find out, and we should be exploring now. I mean, there's the cost involved, but you know what? It's going to get more. It's going to be more and more expensive if we have to do it. If we have to spend, we've got years to work out the bugs. Thinking, but if we're forced to, we got to get out to start putting people on the moon next year, we're screwed here on this planet. We're not going to be screwed when we're trying to land on the moon. We're going to be screwed here. So it's. But I'm one of those. I think we should be spending our money. $8 billion for James Webb. I think that's fine with me. I have no issues. spending money on space exploration, any type of science. I mean, not even to limit it to exploring space. Explore our oceans, our mountains, stuff like that. Everything. I'm a real big advocate for funding science. We 8 billion for James Webb. That's what, 8 days of the Iraq War. I think that the James Webb is a much better deal than what we're getting with the wars we're having. So that's kind of my feelings on all this. I mean, we got to start. I think because like I remember a quote about, for every dollar that gets pumped into the space program, $147 gets back into our economy or gets generated in our economy. I mean, you guys in Congress who are trying to save money, you're wasting all that money. You're cutting. You're you're losing all this stuff, and the United States is losing out because we're cutting our research budget. I mean, I think there was a big campaign when NASA was losing its funding. Send an extra penny to NASA, and that would fund all this, all this great stuff. It's like, wait a minute, our priorities are so screwed up, and if we can get this, we start doing this research, because that research is just not to get a guy up or a rover to Mars, or a guy onto the moon, or whatever. That's technologies that can end up being brought back to terrestrial use, and becomes a profit, for a company here. This is not something, we're not throwing money out into space. It's coming back here, and we're using it, and our computers that we're doing all this talking from is, what was it? The Apollo missions, they ran on 4K of RAM to get to the moon. That's nothing compared to what we're doing right now. I'm sending 4K. I just sent 4K of voice across the internet. It's like nothing. So I think, we got to get our priorities straight. We need to start getting more into research, and really, let's get our priorities straight.
Okay. Thanks, Mike. James?
I second what Mike said. I think we really need to find a way to have the government focus more on scientific research, because just bring back to all the wars we've had in the Middle East and everywhere else we're trying to pick a fight with. We're not going to see any kind of a return on that outside of maybe some really cool looking jets or tanks and a lot of people getting killed for basically no reason. You put the money into scientific research, be it biology, cybernetics, AI, astronomy, exploration, something like that, you're going to get 100-fold return on what you've spent in the long run. Part of the problem is that you're looking at a long run when most politicians are just looking at the next election cycle. So they can't see past their next campaign sticker and who they're going to be running against.
Okay. Let's get a bit more of the international perspective from David Grigg.
You're in Australia. Not going to be an upside down view. But I agree with what's been said. We did talk quite a bit about whether robotic or human version is to be preferred. It's always going to be a matter of both. We're not going to be sending humans out to Pluto anytime soon. I just remember that when I was growing up in the 1950s, the kind of illustrations we had of the planet in our school books were just very vague blobs, even of giant planets like Jupiter. Yeah, we knew there was a red spot on it, but that it. But today we have incredibly detailed images of Jupiter and its moons and planets beyond that. So I think knowledge of the universe is an important thing in itself. Learn far more about ourselves by learning about our place in the universe. So I think we have to keep on exploring in every way we can. Ground-based telescopes, space-based telescopes, humans, robots. We all have to do all of these things.
Okay, and Nick, you get the last word.
I'd like to say that I completely agree with everything that Mike Bohler said, and the others seconded, that space exploration is not merely a matter of exploration, but it's also an existential risk issue, that if we remain stagnant on our planet, we will see the end of everything we know and care about, and money invested is in the space program, we all know returns many times its value. And what we need to do is we need to start shifting the conversation toward more long-term thinking instead of the pervasive short-term thinking. Just in the past 2 weeks, there was an article on the front page of the Financial Times about how there were 5 large companies that between them are sitting on a pile of $1 trillion in basically liquid assets. There's a lot of exploration you could do. With $1 trillion, you could go to Mars and back and still have money left over. But these big companies, we all know they're looking for the next quarter's profits, and they're not thinking of the long term. And if we can begin the process of shifting the social conversation toward long-term existential risk issues and what kind of civilization we want for ourselves and our posterity, maybe people will start to see the value of space exploration and everything that follows from space exploration, including the longevity of our own species.
Great. Thanks, Nick. Well, this has been, I think, an outstanding panel. Hope all of you guys will be back before too much more longer. This is the Unseen Podcast. To learn more about the Unseen Podcast, go to unseenpodcast.com. We're also on Twitter as Podcast Unseen, at Podcast Unseen. If you want to learn more about how you can become part of the panel pool, just send an email to unseenpodcast@gmail.com, and I'll let you know what you can do. And I'd really look forward to everyone's participation. The next week, there will not be an Unseen Podcast. The next episode 9, will come out in early June. Then we'll resume our weekly schedule as planned. I'm hoping that on July 3rd, we can have the time slot to be more of a friendly time slot for our participants in Europe and perhaps South Asia as well, so that they can participate. So that will probably be more like something about 1600 to 1700 GMT. So British summertime, that would be about 6 o'clock in the afternoon. So if you're in Europe and you've been looking for a chance to participate, that will be your first really good chance. And we'll try to do that from time to time, have them at times that are friendly to folks in different time zones. So this is Paul Carr. This has been episode 8 of the Unseen Podcast, and we'll see you again in 2 weeks. And I'd like to thank our panelists. They are in alphabetical order: Mike Bohler, James Garrison, David Grigg, and Nick Nielsen. Music is by DJ Spooky, and we will see you again in about 2 weeks. So enjoy the rest of DJ Spooky's music here of Water and Ice. Good night.